Hello class 8, welcome once more to the chemistry class. So we will do the last portion of the chapter number 4 in your textbook, atomic structure. So today we will specially deal with electronic configuration, the distribution of electrons. So last class we talked about the atomic number and the mass number. The atomic number is represented by Z, and atomic number is represented by Z, and atomic weight or the mass number is represented by the letter A. Now what is atomic number and what is mass number? Atomic number is the total number of electrons, or it is the total number of protons in an atom of an element, whereas mass number is the total number of protons as well as neutrons in the nucleus of an atom of an element. Okay. Now, suppose we have an element X. We have an element X. So we have the atomic mass or the mass number written on the top, on the left hand side of the symbol of an element, and the mass number or the atomic number is written at the bottom. That means it is the superscript and this is the subscript. Okay. This is the superscript and this is the subscript. Like for example, when we talk about sodium, we write sodium Na, the symbol is Na. In the superscript, we write the mass number, that is represented by A. This is the mass number, and 11 is the atomic number, that is represented by Z. So now we can understand that if you have written only Na 2311, the superscript is 23 and the subscript is 11, then we come to know that the mass number or the atomic weight of sodium is 23, whereas the atomic number of sodium is 11. That means the number of protons in the sodium atom is 11. Similarly, the number of electrons, total number of electrons in the atom of sodium is also 11, because atomic number represents the total number of protons and the number of electrons, okay, in the atom of that particular element. Now, with the mass number, we find the number of neutrons. The number of neutrons, how do we find it? How do we calculate the number of neutrons? We calculate the number of neutrons by subtracting the atomic number from the mass number, A minus Z. The atomic mass minus the atomic number. So in case of sodium, it is atomic mass is 23, the superscript, and the number of atomic number is 11. So when we subtract it, the number of neutrons in an atom of sodium is 12. So this is how we calculate the number of protons, electrons and neutrons in an atom, if we know the atomic mass and the atomic number. Atomic mass again is represented by the superscript, and the subscript represents the atomic number. So this is how we find out the total number of protons, electrons and neutrons in an atom of that particular element. Now we move on. So now if we know the atomic number, we know the number of electrons also. So now we come to the electronic configuration. Now what is electronic configuration? We all know that the distribution of electrons in an atom on different shells or orbits in an atom is called electronic configuration. So we have a Bohr-Bury, or Niels Bohr and Charles Bury came together and proposed the electronic configuration, and this is known as Bohr-Bury scheme of electronic configuration. So it does not mean that in different atoms of an element, like for example, let us talk about sodium. So sodium, what is the atomic number? The atomic number is 11. Sodium, the atomic number is, mass number is 23 and atomic number is 11. So we know the number of electrons is equal to, the number of electrons is equal to 11. So there are 11 electrons. So that does not mean that it has a certain rule that we follow. We have a certain rule that we follow in the distribution of electrons in an atom of that particular element. So this is the nucleus. In the center we have the nucleus. Okay, now how do we go about it? How do we find out the number of electrons? Which shell? So shells are numbered 1, 2, 3, 4 and so on. In ICC syllabus we are interested only in 3 orbits. So or it can be named as K, L, M, K, L. K is the first shell, L is the second shell, M is the third shell, and similarly N is the fourth shell. So there we have a formula for it. So the maximum number of electrons in the first shell, in the first or the K shell, how many electrons do we have? We can calculate it by the formula 2n squared. N represents the shell. If it is the first shell or the K shell, we write 2 into N represents the shell. That is the first shell, 1 squared, which is equal to 2. 1 squared is 1, 2 ones are 2. So total number of electrons, the maximum number of electrons an atom have in the first shell is 2. So out of 11 electrons in atom of sodium, we have 2 electrons in the first shell. We have 2 electrons in the first shell. Okay. In the second shell, the maximum number of electrons in the second shell is, again, we use the formula 2n squared. N represents the shell. So 2 into 2 squared. So 2 squared is 4. 4 into 2 is 8. So the maximum number of electrons in the second shell is 8. So we have 8 electrons in the second shell. We have 8 electrons in the second shell in sodium atom. Out of 11, 2 electrons in the first shell, 8 electrons in the second shell, and so we know that 1 electron is left. So we have 1 electron in the last shell. So 1 electron in the last shell. So the electronic configuration will be 2, 8 and 1. 2, 8 and 1 will be the electronic configuration going by the formula 2n squared. So how many electrons can we have, the maximum number of electrons can we have in the third shell by the formula 2n squared. 2n squared is 2 into the third shell, 3 squared. 3 3s are, 3 squared is 9, 9 2s are 18. We can have 18 electrons in the third shell. All right. But there is an exception to the rule here. It says Bohr-Bury or the Bohr-Bury scheme of electronic configuration says that the outermost shell in an atom can have only 8 electrons. Can have only 8 electrons. Okay. So the last shell must have only, maximum it can have is only 8 shell. That's what it says. So the outermost shell, called the valence shell of an atom, cannot accommodate more than 8 electrons, even if it has the capacity to accommodate more electrons. That you have to remember. Now we go on to the electronic configuration of different elements. Okay. So we rub this. I hope you understand this, the maximum number of electrons here. So we do not need this now. All right. Now, hydrogen. When we talk about hydrogen. But before that, we'll talk about 4 shells, K, L, M and N. There are 4 shells that we study here today. Okay. Now, hydrogen. What is that? These are the atomic numbers. Hydrogen, there are 20. We will talk about 20 elements. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium and calcium. The first 20 elements in the periodic table. And we arrange the elements in the order of their increasing order of their atomic number in the periodic table. So first we will talk about hydrogen. So these are the atomic number 1, 2, 3, 4. These are not the serial numbers. These are actually the atomic numbers. Okay. So these are atomic numbers. So hydrogen atomic number is 1. That means it has only 1 electron. So in the first shell we have what will be the electronic configuration? The electronic configuration will be 1. Because in the first shell the only electron it can have in the first shell is 1. So therefore, I'm sure you understood now. Yeah? But before that, let me tell you that in the first maximum number of electrons in the first shell is 2, then comes 8, and then comes 8, and the remaining in the 4th orbit. Please remember this much. This is very, very simple for you to understand without knowing any reason for it. So, I have told you that maximum number of electrons in the outermost shell is 8. We know that, isn't it? So, following that, we can say that in the first orbit, maximum you can have, the maximum number of electrons you can have in the first shell or the first orbit in an atom is 2. Then in the second shell we'll have 8. The maximum number of electrons in the third shell also will have 8, and the remaining on the 4th. So in ICC syllabus we are interested only in the third shell, actually 1, 2 and 3 shells only. So hydrogen atomic number is 1. That means 1 electron. So the only electron we can have we'll have the only electron, 1 electron in the first shell. Helium atomic number is 2. So therefore the first total number of electrons is 2. How many electrons can the first shell accommodate? It is 2. So both the electrons are you will find both the electrons in the first shell. Now lithium atomic number is 3. That means the total number of electrons in the atom of lithium is 3. There are 3 electrons. Out of 3, maximum you can have in the first shell is 2. So we'll have 2 electrons in the first shell. So 3 minus 2, how many electrons left? 1. So that will come to the second shell, that is L shell. So 2 and 1 will be the electronic configuration of lithium. Similarly, beryllium atomic number is 4. So out of 4 electrons, 2 in the first and the remaining 2 again in the second shell. I hope you are understanding. The boron we come to is out of 5 electrons. Now atomic number is 5 means the total number of electrons is also 5. So we'll have 2 electrons in the first shell and the remaining out of 5, 2 in the first shell, remaining 3. Now 3 electrons in the second shell. Now we come to carbon. Out of 6 electrons, 2 in the first shell and remaining 4 in the second. Nitrogen, similarly, out of 7 electrons, 2 in the first shell and remaining 5 in the second, because maximum you can have in the second shell is 8. So the remaining 5 will accommodate in the second shell. Oxygen, atomic number is 8. So in the first shell we'll have 2 and the remaining 6 in the second shell. Similarly, 9. Atomic number is 9. Fluorine atomic number 9. So how many electrons will it have? 9. 9 electrons it will have. So out of 9, 2 will accommodate in the first shell. So first shell maximum you can have in the first shell, the maximum electrons in the first shell is 2. So therefore out of 9, 2 electrons and the remaining 7 in the second orbit. Similarly here neon, in the first shell we'll have 2 and the remaining 8 in the second shell. I'm sure you understood understood. So we go to the next element, that is sodium. Sodium atomic number is 11. As we have already discussed earlier, so maximum you can have in the K shell is 2, and then there are remaining 9. Out of that 9 electrons, we'll have 8 electrons in the second. 8 electrons in the second. 8 plus 2, 10. Total is 11. So 10 minus 11, 1 electron. So 1 electron will come in the third shell. Is it okay? Similarly, magnesium atomic number is 12. So maximum you can have in the first shell is 2. Then 8. Then comes 2 plus 8, 2. 2 plus 8, 10. Minus 12, the remaining 2 here. Now meaning 2 electrons in the M shell. Similarly, aluminium. 2, 8 and 3. I'm sure you are understanding. Silicon. Atomic number is 14. It will have 14 electrons. So out of 14, 2 electrons in the first shell, 8 electrons in the second shell, and the remaining 4 in the shell number 3 or the third shell. Phosphorus atomic number 15. 2 electrons in the first shell, 8 in the second, 8 electrons in the second, and the remaining 5 in the third shell, that is M shell. Similarly, we come to sulfur. 2, 8, and the remaining 6 in the third shell. Chlorine 17. 2 electrons in the first shell, 8 electrons in the second, and in the third, the remaining 7. Now, we come to argon. 2 in the first, 8 electrons in the second, and the remaining 8 in the third. Now, this is interesting now. Potassium and calcium. 2, atomic number is 19. So 2, 8, and the maximum you can have in the third shell is 18 electrons. In the third, maximum number of electrons in the third shell is 18. So we can have 9 electrons, because maximum you can have in the first shell is 18 electrons. It should be 9, but it's not so, because according to the rule it says the maximum number of electrons in the last shell should be 8, not more than 8. So therefore, we write 8 here and the remaining 1 in the fourth shell. Is it understood? Similarly, calcium 2, 8, atomic number is 20, means 20 electrons. 8 plus 2, 10, and the remaining 10 should be here, isn't it? Because third shell, the maximum electrons it can accommodate is 18, but it's not so. But the rule says in the last shell you cannot have more than 8 electrons. So therefore, we'll have, instead of that, we'll have 8 electrons here and the remaining 2 here. So what is the electronic configuration of calcium? 2, 8, 8, and 2. So children, this is all about electronic configuration, and with this we come to the end of the chapter. Okay, so I hope you understood. So thank you for watching.